So now we're taking our first step to solving systems of equations without graphing. We're told without graphing, determine the number of solutions and then classify the system of equations. And by classify it means, is the system of equations consistent or inconsistent, and is it dependent or independent? So our first step is to put both equations into slope-intercept form. With our first system of equations, our first equation is already put into slope-intercept form. We have y equals negative 2x minus 4. So that gives us a slope of negative 2, a y-intercept of 0, negative 4, because in y equals mx plus b, m equals negative 2, which is our slope, and b equals negative 4, which is the y-coordinate of our y-intercept, the x-coordinate being 0, which will always be the case with any y-intercept. Now with our second equation, we have 4x plus 2y equals 9. Subtracting 4x from both sides, we have 2y equals negative 4x plus 9. Divide both sides by 2, and we have y equals negative 2x plus 4.5, or 4.5. So we have a slope of negative 2 and a y-intercept of 0, 4.5. So if we take a closer look at this, we have slopes that are the same. M equals negative 2 in both cases. So their slopes are the same. Their y-intercepts are different. So if we have slopes that are the same, but they don't pass through the same point on the y-axis, that means that these lines are parallel. Since the lines are parallel, there is no solution to the system, and thus our system of equations is inconsistent and independent. And remember, really all that means is that since they're parallel, if we look at a consistent system, it's a system of equations that has at least one solution. Well, this doesn't have at least one solution because the lines are parallel, so that's what makes it inconsistent. It has no solution. It's also going to be considered independent, and the reason for that is because one doesn't depend on the other. The only time we're going to end up with a dependent set of equations, a dependent system of equations, is when we have the case where each equation represents the same line. Now on to our second system of equations. We have 3x plus 2y equals 2. So 3x plus 2y equals 2. Let's solve for y. Subtracting 3x from both sides, we get negative 2y equals negative 3x plus 2. Divide both sides by 2. We end up with y equals negative 3 halves x plus 1. Our second equation, we have 2x plus y equals 1. Subtract 2x from both sides, y equals negative 2x plus 1. So with our first equation, our slope is negative 3 halves, and our y-intercept is 0, 1. With our second equation, our slope equals negative 2, and our y-intercept is 0, 1. Or, sorry. Yeah, the same y-intercept, but different slopes. So we can already tell from this, well, first off, look at their slopes. Their slopes are different. So the lines aren't parallel, and they're not the same line. That means they intersect. And if we just look at their y-intercepts, we automatically know they intersect at the point 0, 1. So because the slopes are different, the y-intercept in this case is the same. It wouldn't matter what the y-intercept was. If their slopes are different and they're not the same line, they're going to intersect. In this case, they just happen to have the same y-intercept, so we already know the solution to the system of equations. It's 0, 1. But what this means is that the lines, since we'll have one solution. So the system of equations, they have graphs that intersect. So the lines intersect. There is one solution. We just happen to know in this case, since they have the same y-intercept, that that's where they intersect. And the system is consistent because it has one solution, and independent because they're not the same line. So in our first example, we saw that the lines are parallel. This means there's no solution to the system. The system is both inconsistent and independent. In our second system of equations, we found that they have different slopes. Different slopes. They happen to have the same y-intercept, but the y-intercept doesn't really matter. If they have different slopes, the lines are going to intersect. They're not the same line, and they're not parallel. We just happen to see in this case that where they intersect is the y-intercept. But because they have different slopes, we know that the lines intersect, there's only one solution, and that the system is both consistent and independent.